Okay, welcome back. We're in the second tutorial of the series for PCB layout using dip trace. And in the first tutorial, what's on the screen is what we got. We managed to lay out our board exactly as it needs to be to fit in our project. We've locked in our nano in position so that our cord can fit through the back of the project and plug into the nano. And the rest of the parts have to fit onto the board in the remaining space. It's not super critical where they go, but I'll show you how I'm going to do it, and you can decide what you want to do. So next thing, we have all these parts that we've designed, and we need to place them on the board. There is better ways and worse ways of doing it based on the fact that they all need to be connected together with traces. So if I just place them willy-nilly, like that, and I go, wow, that's the way I want it, that looks easy. Well, my next step is to start up something, and there's a shortcut right here called auto router. It's also underneath root. You can go auto root or root all or something like that. There it is, run auto router. And what the program's going to try and do is it's going to try and connect all of those components according to those lines and create you a circuit board. So let's try it, run auto router. Now, it didn't do too bad. I just threw them on there any old way, and I got that. Now, what is this blue line remaining? Well, that means the program tried, but it couldn't complete a connection here. So we know that these can connect together if we get them right. So we are going to try and do that. There are times when you just can't. And that's when the other side of a two-sided board could be useful, because we could make the connection on the other side, but we can't do that with our single-sided copper board. The other option could be, at the very least, put a jumper wire across. So create another pad here and another pad here and connect the two with a jumper wire. We try and avoid jumper wires at all costs. So let's unroot. So we go up to root and unroot all and see if we can get this better. Now I'm doing a bit of a cheat because it does take a bit of trial and error to get this, but what I've got on my other screen is something that I've worked out earlier that is a solution to this problem. So I'm going to move this back here and see if we can recreate it. Okay, so the first thing we're going to do is you're going to just move these back off like this, like this, like this. Drag them away. And let's start with the one at the top, the 220. Mine on my cheat over here is over here somewhere. Let's just throw it in like that. Then I'm going to grab the servo. I'm going to bring that in here. Now, this blue line is my data line connected to pin 9. So if you count up all these pins, you'd end up at 9. And that's the one that should be facing this. If it's turned around, because you can turn these around, I'll show you. There we go. We pick it so it's blue, and then you hit your space bar on your keyboard, and you can rotate it 90 degrees at a time. You need it to be in the position where this is going straight across, and about there. We'll leave that for now. Now we're going to put the LED in. The LED I'm going to turn. I'm going to click it until it's blue, and then I'm going to space bar it until the flat side or the negative side of the LED is facing down. That seems to go about here. And then the 10K ohm, I've got it down here somewhere in my other one. And then the switch, I've got it down here, like that. Just maybe a little lower. There we go, something like that. So those are the connections for the switch. The wires go up to the switch, which is sticking out the top of the box. Okay, so let's see if this can do it. Let's run the auto router. Boom. And there we go. Now we have a bit of a problem in that the 220 ohm resistor has an issue right here connecting that to that. So it looks like I've got some space to work with. Maybe I'll just drag it up, and a little different than my other board. And this switch here looks like, oh, it's kind of funny. So I'm going to maybe rotate it, but I can't rotate it. And I'm going to unroot, unroot all, and I'm going to run the auto router again. Now it's looking pretty good, except for some reason this 220 ohm resistor can get straight to here, but it can't connect to here. Now what you can do is you can start looking for ways to do it yourself. If you can find a way to do it yourself, you can up here root manually, and you can start clicking and start connecting things like this and trying to get to where it needs to go. I need to get here, and it doesn't look like there's a way yet because everything's blocked off. So let's continue. Control Z. Control Z in most programs gets you out of things, or escape. There we go. So what's our solution? Our solution is to keep mussing around with it until you get it. That's all. There is no solution here other than that. And it's probably going to take me too long to do that here. So I will go back to this and show you what I had. Boom, on mine that worked. It's pretty much the same thing. And you can study that. You can pause the screen and you can see what I did. Or you can just play around with yours to get it to where you need to be. That's all you have to do. Now, you'll see on mine, and let's see if I can turn this off over here. Boom. I have something else, like you're just looking at this right now, and that's called a copper pour. And that's what I'm going to show you how to do now, because we need to be able to do that. Even though my board is not finished, I'll do a copper pour anyway. So to do a copper pour, which saves us a lot of etchant chemical that we're going to use to get rid of the process or the copper. And I know this seems weird at the moment because you don't know what that is, but trust me, it's a better way of doing things. So before we do that, we're going to do some keep outs. So our copper pour leaves us a bit of a zone up here. So what we're going to have to do is head up to the geometry tab here, place a shape. And I think I did circles last time because I thought it was cool, but you know, who am I to say what's cool? I'm going to grab a circle. I'm going to maybe turn my snap back on. View. Snap to I am on. Good. I'm going to pick here, upper left. I'm going to pick here like that. I just wanted to not have any copper in this zone because when my screw goes in, I don't want it to perhaps start short-circuiting, connecting things that shouldn't be connected. So I'm going to make sure right there and right there and right here and right here. Let's go, is it right there? You have to pick the outer corners of your circle. That's what I'm doing. There we are. Okay, so that's all I want to do is put those circles in, and now I'm going to place this thing called a copper pour. Pretend this is working. Now, placement. Sorry, it's under object. You go copper pour, place a copper pour. Once you pick this, you can just pick your four corners. 1, 2, snapping to the grid. When you get to your last corner, don't move your mouse because you don't need any more corners. Just put it right there and hit enter on your keyboard. These are the defaults and usually they're just fine. So let's just go with them for now. We'll push OK. And oh, I'm looking at the wrong side of the board. There we go. I'm looking at the bottom side of the board now. So what has this thing done for me? Well, it means that instead of removing all of the copper on the board when it's etched, which is totally unnecessary, it will remove just these areas here, which are around our traces. Now we seem to have a bit of a problem with our copper pour, because if I look at my other one, pull this over for a second and turn on my copper pour, you can see that there is you can call it like a moat. there's a gap all the way around my traces, and these are truly looking just like little wires that connect things together, and that's what we want to see. So when you do your copper pour, and notice I kept it out here by doing my circles, and these are obviously a little different shape circle, but that was the idea. But that's what we're looking for when we place the copper pour. Not exactly sure at this moment in this video. I don't have time to diagnose why it isn't quite looking that way, but I'm sure yours will work out. If it doesn't, call me over and we'll fix it. But we're looking for a nice copper pour like that. Now, the last thing you're going to do with this is you're going to go to File, and you're going to go to Preview, and you're going to look at your board. I can zoom in by Control and scroll, but don't change the print scale. You want to see it proper size, but you can control and scroll in and have a look at it. We're going to look at the bottom of the board, and we're going to print this out so we can actually physically look at this and make sure everything's looking okay. And then we'll also be able to trace this and make sure all of these connections are as they should be, going to where they should be based on our schematic, right? So if I come out of pin, again, pin 9, I should be going to my servo, and then the middle pin of the servo should be going to positive, and the outer pin of the servo should be going to ground. Well, if I head back here, not that one, this one, I come out of pin 9 here and I go to servo, that means the middle pin should be going to positive, and if I follow that around, it goes to the positive on my nano. And you can also turn on both layers if you want, all layers, and you can sort of see the component markings through there, or you can just put on the top. But you basically have them side by side and you start comparing them and making sure all your connections are good. You can also do it here, there. Putting this one over there, putting this one on the other side. Let's see if I can make it smaller. And put them side by side and compare the two. And make sure that the connections are what they should be. It's kind of a last minute. I mean, they should be, but strange things happen. Okay, that will get you to the printout. That will get you to me. We can discuss the final steps at that point. That's all for this video.